On August 5th, 2025, Earth spun faster than usual. So fast, in fact, that our day was shorter by a fraction of a second. You didn't feel it. You didn't notice it. But the most precise atomic clocks on Earth did, and scientists are baffled. This isn't supposed to happen. Our planet's rotation does change, yes, but usually it slows down over time. Do not speed up. And yet, here we are, living on a world that for one day ticked just a little too quickly. So what's going on? Is this just a harmless quirk, the planet's version of a hiccup? Or is it a warning sign of something stirring deep beneath our feet, inside Earth's molten core? Earth isn't a perfect, unchanging clock. It's more like a spinning top, wobbly, unpredictable, and influenced by everything around it. Gravitational tugs from the moon pull at our oceans, creating tidal bulges that shift Earth's mass. Winds stir the atmosphere, and even massive earthquakes can redistribute Earth's mass, altering its spin. Think of it like a figure skater pulling in their arms to spin faster. When Earth's mass shifts, whether from melting glaciers, seismic activity, or atmospheric changes, it affects our planet's rotation. So, how do we know when Earth spins faster or slower? Enter atomic clocks, our most precise timekeepers, accurate to within a second every 100 million years. These clocks measure time by the vibrations of atoms. By comparing atomic time with Earth's rotational time, scientists can detect variations as small as milliseconds. Over the years, Earth's rotation has been slowing due to tidal friction from the moon. However, recent data indicates short-term accelerations, like the 1.33 millisecond shorter day on August 5, 2025. These tiny changes matter. Systems like GPS, stock markets, and internet infrastructure rely on precise timing. A shift of even a millisecond can cause synchronization issues. While we didn't lose an hour of sleep, the mystery lies in why Earth spun faster that day and whether it's part of a larger, ongoing pattern. So, if Earth isn't just randomly glitching like a broken clock, what is behind these faster days? Scientists have a few leading theories, and each one takes us deeper into the hidden forces shaping our planet. Theory 1. The core mantle connection. Deep beneath our feet, thousands of miles down, Earth has a molten, churning core. Think of it as a giant liquid engine made of molten iron and nickel, constantly swirling. Sometimes the core and the outer layers of Earth don't spin at exactly the same speed. When that happens, it can nudge the planet's overall rotation, just enough to make a day shorter or longer. In other words, our planet's own heart might be beating a little faster. Scientific insight. Recent studies have shown that the Earth's inner core has undergone changes in its rotation speed and shape over the past 2 decades. These changes could influence the planet's overall rotation and the length of days. Theory 2. Melting glaciers and shifting weight. But there's another possibility, and this one's connected to us. As glaciers in Greenland and Antarctica melt, trillions of tons of water move from ice caps into the ocean. That redistribution of weight changes Earth's balance. It's like a spinning figure skater. Pull your arms in. And you spin faster, stretch them out, and you slow down. In this case, melting ice is like Earth pulling its arms in, and the spin speeds up. Scientific insight. Melting polar ice caps redistribute mass from the poles toward the equator, causing the Earth to become bulkier at the equator. This redistribution of mass leads to a slight increase in the Earth's rotation speed, shortening the length of a day by a few milliseconds. Theory 3. Earthquakes and seismic jolts. And then, there are earthquakes. Massive ones can literally shift the axis of the Earth by centimeters. That's small on a human scale, but on a planetary scale, it's enormous. Imagine giving a spinning basketball a quick tap. It keeps spinning, but the motion changes ever so slightly. Some scientists believe past megaquakes may already have trimmed milliseconds off our days. Large earthquakes can redistribute Earth's mass, leading to changes in the planet's rotation. For instance, the 2004 Indian Ocean earthquake and the 2011 Japan earthquake both caused measurable shifts in Earth's rotation. So, is it the molten core stirring, ice caps melting, or the planet shaking itself into a new rhythm? Maybe it's all of the above. What we do know is that Earth's spin is far from stable, and that raises an even stranger question. Humans have noticed shifts in time before. What did our ancestors think was happening when days didn't feel quite right? Humans have always been obsessed with time. Long before atomic clocks, ancient civilizations watched the skies, tracked the sun, the stars, and the seasons. Even the slightest shift in the rhythm of the heavens wasn't just curiosity. It was a message, sometimes ominous, sometimes divine. Take the Mayans. Their calendars were remarkably precise, able to predict eclipses and planetary cycles centuries ahead. They saw time not as a straight line, but as a cycle, loops of ages, eras, and cosmic shifts. A shorter day, or any disruption in the sky, could be read as a signal that a cycle was turning, or that one age was ending. For them, time slipping wasn't random. It was destiny unfolding. In Norse legends, time could behave strangely. Heroes might spend a day in a mystical realm and return to find years had passed. Celtic fairy tales are full of travelers lured into enchanted forests where time seemed to freeze, only to race forward once they left. To these cultures, time wasn't a constant march. It was fragile. It could stretch, shrink, or vanish. Even today, people are fascinated by lost time. Some point to the Mandela effect, the idea that collective memories differ from recorded reality, as evidence of shifting timelines. A day that's just a millisecond shorter might not matter scientifically, but to those who see anomalies in memory or history, it's proof we might be slipping into another version of reality altogether. So whether it's Mayan prophecy, Norse sagas, or modern internet lore, humanity has always been uneasy with the idea that time can bend, warp, or vanish. And here's the twist. Science says tiny shifts in day length do happen, thanks to Earth's wobble, molten core, and moving ice. The real question isn't whether time can slip. It is whether we should pay attention when it does. So, should we panic about these ultra-short days? Absolutely not. Earth isn't about to fling us into space, and we're not suddenly living on a planet spinning like a fidget spinner. Tiny variations in day length, milliseconds here and there, are normal. Our planet has survived billions of years of wobbling, shifting, and spinning faster or slower, and it's still going strong. But humans like precision. That's why we built atomic clocks, the most accurate timekeepers ever. And because Earth's rotation isn't perfectly steady, atomic time can drift slightly from solar time. That's where leap seconds come in. A single second added, or in theory removed, to keep atomic clocks aligned with Earth's rotation. Small? Yes. Critical? Absolutely. Without leap seconds, GPS satellites, financial networks, and even everyday timekeeping could slowly drift off reality. Not everyone loves leap seconds. Tech companies like Google and Amazon have suggested phasing them out. Why? Because when a leap second occurs, computer servers can glitch, databases can freeze, and high-frequency trading systems can stumble. Even in our digital age, time refuses to obey exactly what we want. Earth keeps its own schedule. So, no need to stockpile alarm clocks just yet. These tiny lost milliseconds are a reminder. Time isn't as rigid as it seems. Earth is alive, spinning, wobbling, shifting, and every once in a while, it shows us just how mysterious our planet really is. Let's play a little thought experiment. Imagine Earth kept spinning faster and faster. Days shrink to 23 hours, 22, even 20 hours. Suddenly, lunch breaks feel rushed, sunsets arrive before your coffee cools, and your calendar struggles to keep up. Life as we know it speeds up. Would we age quickly? Technically, our biological clocks wouldn't change. Your birthday still comes once per orbit, but the rhythm of daily life would feel compressed. Monday might feel eternal, or mercifully brief. Your snooze button becomes a precious lifeline in this fast-forward world. And yes, your coffee would brew faster than your heart rate. Of course, this is all imagination, but it is fun to think. Earth's tiny hiccups in time remind us that our planet is alive, unpredictable, and maybe just a little mischievous. So here's the takeaway. Earth isn't a static stage. It's alive, spinning, shifting, and surprising us in ways we're only beginning to understand. Even tiny changes of a few milliseconds reveal enormous hidden forces at work beneath our feet and above our heads. From the molten core to melting glaciers, from earthquakes to ancient myths, time on our planet isn't as rigid as we imagine. Every day is a small miracle, a subtle reminder that we live on a world that's dynamic, mysterious, and delightfully unpredictable. And now we turn it over to you. What do you think is behind Earth's shortening days? Pure science or something stranger? Share your theories in the comments. And if this video made you pause and rethink how we measure time, hit like and share it with a friend, because who knows when Earth might surprise us again.